So my name is Marcus. I'm the product manager on Google Cloud, working on Gemini Code Assist, and I'll also be joined later today by Hockman, another product manager focused on code customization, and Mayank Chandra, senior director within Capgemini, who'll be sharing more about their experience using Gemini Code Assist and code customizations. So as for the overall session for today, we start by giving you a quick overview of what is Gemini Code Assist, the key problems it addresses for customers. Then we'll dive deeper on why is context important and the effort we'll be doing to extend the contextualization of Gemini Code Assist. And we'll then wrap up with a quick testimonial from Capgemini and their developer experience with Gemini Code Assist, right? So let's start. So Gemini Code Assist. The key idea here is Gemini Code Assist is the evolution of Duet AI for developers. You'd expect to get the same capabilities our customers are used to getting, such as code completion in your preferred code editors and IDEs, such as VS Code or IntelliJ, code generations, a chatbot which allows you to ask questions about code on your code editor, as well as smart actions, allowing you to select a piece of code and perform contextual actions such as generating unit tests or getting code explanations. On top of that, we are now bringing the power of Gemini to Gemini Code Assist. So essentially, starting today, our users can get Gemini Pro within Gemini Code Assist. In addition, one of the key principles we follow from the very beginning on Gemini Code Assist is to make our products enterprise ready. This means essentially having the IP protection, security, compliance controls customers need to ensure they are responsibly providing Gen AI solutions to the development teams. And since our launch in December 2023, I'm excited to say that we now have 5,000 organizations actively using Gemini Code Assist on their day-to-day, including many folks here likely on this audience. So I want to take some time as well to thank you for all of your trust and all of your very useful feedback, which helped us shape the product we are building here. All right, so one thing I want to talk about first is the issues our team is working on addressing, right? So before we even started building Gemini Code Assist, one thing we did was talk to multiple customers to understand what were the key friction points which are holding their teams back from achieving their optimal software delivery velocity. We found a large array of issues and challenges, but those are the 4 key categories of issues we saw here, we heard again and again. You likely can resonate with some of those. The first one is slow developer onboarding. Essentially, the long time it takes for a developer who's new to a team, or is starting to work on a new code base, or is trying to call an API or a microservice they may not be familiar with. And the long time it takes for them to be able to confidently read, write, and review code on a specific code base. In some cases, taking days or even weeks of time. That's a good area. You can see this contextual AI assistance allowing developers to more quickly be confident and start writing and reviewing code. The second big area is excessive context switching. We've likely all been there. You're trying to write code, and you quickly find yourself with 40 different open tabs, 10 on Stack Overflow, 5 on documentation, different GitHub repositories, and have to juggle all that information on your mind. The key idea here is to reduce the context switching this creates and the cognitive overhead distracting developers from the core tasks is to move all of those to a central focal point, essentially either a chatbot within your IDE or contextual code generations and code completions. Third item here is high maintenance costs and tech debt. So software delivery is not just about delivering software faster today. It's about also having a code base which is maintainable over time. And one key pattern you see is code bases tend to grow in complexity and size over time. And with that comes the typical tech debt challenges, which we see AI being well suited to address by enabling capabilities such as better code documentation or better unit test generation or enforcing your coding practices while your developers are developing their code. And the third one is excessive repetitive tasks, essentially simple but often occurring tasks that are structured enough that they're a good fit to be streamlined or automated with AI, such as commenting code, writing unit tests, and doing refactoring for sake of readability purposes. Those are the four core problems we focus on with Gemini Code Assist. Another thing I want to mention here is that all Google Cloud developer tools follow a principle of meeting developers where they are, right? So no developers have a myriad of inner loop, outer loop developer tools where they have built the workflows over, in many cases, years, where they can achieve the optimal productivity. Gemini Code Assist also follows this principle, and the way you do that is by supporting the most popular code editors and IDEs, such as IntelliJ, PyCharm, VS Code, Cloud Workstations, Cloud Shell Editor, and many more IDEs to come, including Android Studio, which is currently in the works and coming soon. All right, so another point here. So which areas to provide AI assistance? One of the key principles we follow within Gemini Code Assist is providing assistance not just in the code editor, but across the entirety of the software development lifecycle. The key idea here is software goes through many steps, you can see here, right? So, and the key idea here is for Gemini Code Assist to connect with those services and provide contextual assistance. For example, during the design phase, you can essentially converse with a chatbot to brainstorm and prototype a basic application even before you start writing code. As you're building, you can get code generations. After you build, you can get tests. You can get essentially automatic unit or integration test generation. And even as you get to the outer loop, you think about deployment. You can imagine essentially you are managing your infrastructure as code. So Gemini Code Assist is fine-tuned on dialects, such as Terraform, Kubernetes Resource Manager, or G-Cloud to help you manage your infrastructure, and as well as troubleshooting after an application is deployed. You can leverage tools such as Gemini in Crashlytics or Gemini in Firebase to get assistance with troubleshooting crashes, ANRs, or errors in application. The key idea here is each of those steps together represent an opportunity for improvement in the software development lifecycle. And you can see essentially Gemini being contextually injected on all those elements of your lifecycle. The second point I want to make here is Google was the very first customer of Gemini Code Assist. Even before our product was live, we had thousands of Googlers with approval for using Gemini Code Assist for production and day-to-day development tasks. This meant a much tighter feedback loop, essentially allowing us to try new capabilities and have capabilities which were tested and validated before we can give those to our customers. So essentially, all this internal usage of Code Assist helped us ship more stable and more reliable capabilities to our customers. And beyond that, just to drill down a bit further on that, Google as a company has been spending decades experimenting and investigating and researching ways to make developers more productive, more satisfied, and more engaged on their day-to-day work. You can see here some sample publications, such as the annual data reports or the SRE or software engineering books which Google published. You can essentially see Gemini Code Assist as our delivery mechanism to bring the latest GenAI capabilities which are used within our developers to our customers as well. The key idea here is having a large number of engineers in the tens of thousands order allows us to do comprehensive A/B experiments to not only validate a feature has a good developer experience, but also that it is having a bottom line impact in productivity gains. Finally, I just want to talk briefly about the new features which were introduced this week at Cloud Next. Right, so 3 key capabilities. First one is Gemini Pro. As I mentioned, it is available now generally to all customers. If you download Code Assist today, you get the power of Gemini Pro 1.0 for chat and code generations. In addition, code customization will be the core focus of the session. Andrew will be talking more about, but essentially provides you with additional local context, meaning fetching multiple files from a local workspace, in addition to a remote approach, where you can essentially customize Gemini Code Assist on the entirety of your private code repositories. The third part here is code transformations. The key idea here is focusing on existing code, essentially taking your existing code and allowing you to use natural language prompts to perform modifications on that existing code. Some examples here could be you want to make code more readable, or you want to document code, or you have code which is not performing well. You want to get ideas for how to optimize the performance. That's essentially what code transformations enable you to do. in addition to be complemented with Gemini 1.5 with 1 million tokens to enable you to expand transformations, taking into account the context of your broader code repositories. Folks, with that said, I'll now hand over to Andrew Hockman, who'll be giving a deep dive specifically on context and code customization.
Awesome, thanks Marcos. Hey everybody, I'm Andrew Hockman. I'm a product manager with Google Cloud working on Gemini code customization and analytics, which is hopefully why you're all here today, so you're in the right place. Before we get started, I want to talk about the importance of context in software development. So this is Seattle, where I live, and if you look in the upper right-hand corner there, that little blue dot, that's me sitting at the Google Kirkland office capturing the screenshot, and on the left-hand side of the screen is a red pin, that's the Google South Lake Union office. And I visit both of these offices and have to travel between them on a regular basis. And you know, this is pretty simple, right? Point A to point B. We've been doing this for 20 years, where you'd use some of those search algorithms you may have learned back in school, get shortest path, shortest distance, turn-by-turn directions, easy stuff. But the problem is that Seattle doesn't look like this. Normally, Seattle looks like this. There's traffic, there's wrecks, there's blocked lanes. Suddenly, the context of my environment becomes very important when I navigate, because I might want an alternate route. I might want to pay extra for a toll road. Or it's even worse if I'm using a different modality. Maybe I'm on a bicycle, and now I'm more concerned about protected lanes, and I'm concerned about elevation changes. Knowing the context of the environment is so important. Context matters. So, how does that relate to software development? Well, we already know that Gemini is great at helping developers write better code faster. We have a large language model that's been trained on a bunch of code, so it's fine-tuned with a lot of different languages. We have IDE integrations with our plugins. We have prompt engineering to help handle very specific cases. However, for some enterprise developers, it's a little bit like the traffic map with no traffic, because you can get good instructions that get you where you need to go, but maybe there's a better way, because your enterprise environment might actually look a little different. Maybe it looks something like this. Maybe you have a legacy component that doesn't have security, and so you've wrapped it in an auth wrapper. Maybe you have a logging solution with custom pieces. Maybe you're in the middle of a large code refactor where you're moving customer data between different services and database schemas, and so you have a storage layer to route the data requests. All of these cases are private APIs, APIs that exist only in your environment and don't have any representation in the model training set. So your AI assistant needs to give you recommendations that match your API, and even your house coding style. And that's where Gemini code customization comes in. Gemini Code Assist allows enterprises to get results that are specific to their local environment. So let's talk about some of the ways that we can do that, and we'll start with one that we didn't use, and that is fine-tuning. If we were here a year ago, we would all be talking about fine-tuning and LoRa layers. But fine-tuning, although it does give you better results in the base model alone, it is expensive. You often need ML engineers to get your data set for your training. You have to run that GPU, which matters a lot to your CFO. And your code evolves. Just like my traffic map, your code is not going to be the same tomorrow or next week or next month or next year. In fact, when I was working with another large organization, we were trying to do this same thing, fine-tune a model for a bunch of developers on a bunch of internal code, and just to keep up with the code base churn, we were estimating we would have to retrain our model at a minimum once every 6 months. And so what are you going to do? You're going to keep retraining every 6 months? What happens when there's a new base model that gets released? Do you have to retrain for the base model, or do you just let your developers fall further and further behind? And what about developer permissions? We would love to live in a utopia where every developer has access to all the source code in the entire enterprise, but we know most enterprises don't work that way. One team has access to this repo, one team has access to this repo. You can make a separate fine-tuned model for each of those teams. We think we can do better, and we can do it with the power of context. So we already know local context. Local context where you have the prefix and the suffix, the code around your cursor, snippets from your active code file, snippets from other code files that are already open in your IDE. We do this today. But we're also proud to announce here at Next that we have already shipped support for local context. Files that are in your local environment that are located next to the file that's currently being edited, even if they're not checked in, we're able to look for matching code snippets and provide that to the language model so that you get better customized results right away. Again, this is available for everyone in all of the extensions that are currently available for our IDEs. So you can get this today. But for enterprises, we can do even better. For enterprises, we have remote customization. With remote customization, now you can get code from your private source repository and fuse that with the prefix and the suffix and the local code so that you can get a much better solution for your enterprise. It doesn't matter if you haven't checked out that code repository. All of this is in the cloud, and it's available to your entire organization. So Gemini code customization is complete. We are able to include data beyond the developer environment, including multiple private source code repositories. It stays up to date. So as you make changes, you can check in a change today, and it can be available for other developers in your organization as soon as tomorrow. And when new base models come along, those just plug right in, and you don't need to retrain. You get all the value of code customization without the GPU time investment. And Gemini code customization is secure. You're able to limit access to specific source repositories for specific groups of developers. And of course, your code stays private. Google does not see your code. We already have support for top languages: Python, Golang, Java, JavaScript, TypeScript, Rust, Kotlin, and coming soon, C, C++, PHP, and a bunch more. We're going to be adding support for a ton of languages, so this is where we really want to hear from you. If you are here in the room today or you're watching online, if there's a specific coding language that's a high priority for your organization, reach out so that we can prioritize. We're still going to build a whole bunch of these, but we want to do them in the right order so that we can serve you best. So how do we connect your private source repository to a language model? Well, that's where we use Developer Connect. Developer Connect builds on our already excellent Cloud Build Repositories product. It securely connects GitLab, Bitbucket, and GitHub. We're going to be offering both cloud and SaaS deployment support as well as on-premise support for your code repositories. Developer Connect is announced here at Next in private preview for GitHub Enterprise Cloud, with more source code management configurations to follow in the coming months. We're able to index code from multiple source code repositories. So if you make a connection to GitLab, you can choose to index some of your repositories, all of your repositories. You can create multiple projects inside Google Cloud Platform that are using different subsets of the repositories that you've linked and expose those to different developers so that your developers only get access to the right code suggestions. And Developer Connect, as I said, it's in private preview now. And so now let's go and we'll show a little demo video to see how this works from our friends at Turing. So our friends at Turing sent me this video, and it shows their internal logging component. And so this is actually back-end processing for a chat bot that's on their website. And you see they have a thing called the Turing logger, and the Turing logger is a custom logging component that adds just a little bit of extra data around their logs. And so when they are processing any kind of an incoming request, then they want to log this with the Turing logger so that they can do analytics on it later. So let's go back to our main file here. And if we're just using standard Gemini, which is pretty great, we're going to say Turing logger.log with a string, like every log message you've ever seen before in your life. No surprise. Good suggestion, but could be better. So let's see how we can do this with code customization. Once we link the private source code repositories from Turing, now we see that we understand that the log message is actually a key and has some additional metadata that comes with it. Now, because this is a video, I could have just edited out the fact that it said chat trigger. I left this in to show you that this is real. The first suggestion was chat trigger, which is a decent one. We're actually going to do a chat agent key for this one. So let's go ahead and do chat trigger, and we'll erase. We're guessing chat show. Let's say chat agent. And what happens? All of a sudden, we get all this extra metadata suggestion. This is unstructured data. The city, the state, the country. This is important information for Turing so that then they can get that analytics from the bot presses on their website. But think about the developer that wrote this. They didn't have to go look up documentation. They didn't have to know that this was here. This just happened automatically and helped them do the right thing the first time. So how does this work? Well, we have your private source code repository that connects through Developer Connect to the AlloyDB code index. And so you notice that Developer Connect in your configuration store is running inside of VPC in your private customer project. Then the code indexer and AlloyDB runs inside a single tenant project so that at no point is Google looking at your code. At no point is your code stored alongside other customer code. This allows requests from the IDE to pass through Gemini Code Assist, pick up that extra context from LIDB, and pass it to Gemini for a better result. Let's break down the indexer a little bit more. So we've got your code, and we parse it into chunks, and we parse those chunks into tokens, and then we generate embeddings, and we store that in the snippet store. We are built for large repositories. We have gotten requests from customers for 100 gigabyte source code repositories, for small source code repositories that have 15,000 individual repos. These are the type of scale numbers that our engineers are thinking about. And if you don't want to index your entire source code repository, we're adding support for AI ignore, which works just like a git ignore and allows the indexer to skip over certain portions of your source code that are not relevant. Let's go down one more level. Into the indexer, we use semantic embeddings. This is so important. If we look at just the combination between, for example, example 1 and example 2, these are actual tests that are taken from some of our internal data. 1 and 2, they are semantically similar. They do the same thing, but they look different because one is using an indexer and one is using an iterator. 2 and 3 look the same, but are doing two different things, calculating the mean and the max. With semantic embeddings, we're able to get much better results so that we're able to match the meaning of your code as you're typing in your IDE and find relevant suggestions from your private repository. Gemini code customization connects to multiple source code management providers. You are able to create multiple projects for developers with specific repo access. We have immediate support for the top languages, and we filter your index code by file or subtree. The index remains local to your project. So, of course, the question everybody asks next is, how do I sign up? Here, go ahead and scan the code. We are excited to make this available today in private preview. Private preview means that we will need some help to get you onboarded. We're not going to support every configuration right out of the box immediately, but this is going to be a way for some of your large enterprises to get started, and then we'll be adding more support over time. Now, of course, all of this is built on the assumption that we're going to make developers more productive. So how do we measure productivity? This is the question. When a measure becomes a target, it ceases to become a good measure. Who's seen this? Who's seen this cycle? We need a simple productivity metric. Our metric's been gamed. Suddenly, our developers are checking in half as much code twice as often. I've seen this. That's real. Okay, we need a nuanced view of productivity over the entire software development lifecycle. And now these numbers are too complex, and our investors don't understand. Wall Street doesn't understand. Some of our leadership doesn't understand. What we need is a simple productivity metric. And around we go. So if we think about some of the metrics that we find valuable, no metrics are perfect, some are useful. Operational metrics like model accuracy from whole fill, human raters, acceptance rates, generated characters, how many characters make it into the repo. And then some of those value metrics like developer sentiment, the diff count per dev per month, the amount of productivity in the inner loop development time, and larger frameworks like Dora or Space. Some real results, fill in the middle scores. Code customization, we see a 20% improvement in similarity scores using remote code customization versus base model generation. Human raters, we see more code generated and we see a higher pass rate from human raters when we're using code customization over the base model generation. Online results, with Turing, we saw in an A/B test over a 70% relative change in the acceptance rates for customized code with our private repositories versus the base model. And this is a point-in-time measurement. The base model will continue to get better, will continue to change, but we expect to see durable improvements with code customization. Turing reports productivity gains of around 33%. That's huge. And Wayfair, faster environment setup time, higher unit test coverage, more satisfaction from developers. So when's it coming? Right now, we have operational metrics, some basic telemetry available from our enterprise customers. So just if you are a customer of ours today, we can deliver that to you. It's a little bit manual, but we are there to help you out. Right now, what the team is working on very, very quickly is providing that private preview data access for enterprise customers so that you can pull some of this telemetry yourself. And then as we look further out into the year, additional operational data, such as dashboards, additional data for enterprise analysis, and then some of those value metrics, which are going to be defined in conjunction with you. So if you want Dora scores, if you want changeless per dev per month, if you want to look at cycle time, tell us what's important because we want to help you measure the way that you want to measure. Metrics will evolve, and we're going to be evolving right along with you. So I've been talking a lot. I want to hand this over now to Mayank from Capgemini, who's going to tell you about some of their experience with developer augmented productivity. Mayank?
Thank you, Andrew. Good morning, everyone. I am Mayank Chandra, part of Capgemini, and today I'm going to talk about the generative AI for software engineering, our pilot experience of how did we do it using Duet AI, now it is called, Gemini Code Assist, and the way we went about measuring it, how we did a pilot, and the outcomes, which some of it you heard, through Andrew right now. So before we get started, a quick view of Capgemini. Capgemini has been working with clients in AI and generative AI for years to respond to their specific business needs around life sciences, consumer products, retail, and financial services. We have been focusing on large language models, for example, synthetic data generation, chatbots, and code conversion. GenAI technology is now reaching industry maturity, although there are many, many challenges to address before they are able to deliver reliable, tangible business outcomes. We are ready to work hand in hand with clients and ecosystem of partners to achieve this. Our group CEO, Ayman Azad, announced last year a €2 billion investment over the next 3 years to strengthen our leadership in this space. We are convinced that this new technology wave will accelerate the transition to a digital and a sustainable economy. We are excited about the possibilities that these new technological advancements open for our clients, and we will drive a strong demand for our services. Okay, so if we talk about software engineering, right? Every organization wants to release quality software fast enough to keep up with their seemingly endless, growth demands which are there, and has an ultimatum to release this faster and faster, right? According to a recent Capgemini Research Institute, a survey across 800 organizations, 67% of executives see the most potential for generative AI in the IT function is to drive innovation and create value. At the beginning of 2023, Capgemini started a large-scale program with the aim of measuring the impact of GenAI on software engineering productivity, quality, security, and developer experience. These pilots focused only on the coding activity within the software lifecycle. Capgemini deployed a reliable and a consistent measurement protocol for ensuring comparable and representative results across experimentation. We are learning, documenting, and packaging best practices for generative AI adoption through various technologies and architecture solutions. Now, before we go into the pilot, let's understand our pilot approach. So our pilot approach was primarily driven by the fact that how we can measure the productivity of a team which is working on a regular basis and bring in GenAI for them. And the other aspect was how we can do it in a multi-team approach where we can have the current team, baseline team, do the work as it is, and have another team, which is a low pyramid team, come and enabled by GenAI, deliver the same work into the same time frame. So this is where you see a single team approach where they started with a pilot. We baseline all the measurement and the metrics which we want to start with and make them run for almost 18 weeks with 3 releases, each release for 6 weeks, and it had 3 sprints. Similar exercise with multi-team approach had with a balanced team, which was there. They start working in the same time frame without any AI, and a low pyramid team with AI. Now, what is a balanced team and a low pyramid team? A balanced team was a team of 1 tech lead, 3 senior developers, and 3 mid-level developers. A low pyramid was a tech lead and 6 of junior developers. So that's how the difference was between a balanced team versus a low pyramid team. So what was our pilot phases and how we approached this? So if you look at, we started with a preparation phase. In the preparation phase, we wanted to ensure we first of all identify teams. We look at the use cases in detail. We look at the tool sets which we are going to use, the measurement, how are we going to do the measure, all the productivity aspects. And the biggest part was legal and security approvals, because that does take time. So that was the biggest effort when we were doing the preparation of it. And that was like, a couple of weeks. After that, we ran the execution and the measurement for next 18 weeks. Now, as we go through the measurement was around calculating productivity, the quality metrics, run cast scan and sonar cube code quality metrics, and this was all done using agile boards. Now on the execution side, if you go, we conducted baseline assessments, like when we started the whole program. After that, we execute the projects in 9 sprints, across those 18 weeks, which we mentioned, and then conduct assessment at the end of every sprint. So measuring during the whole path was very, very important. We ensured we have to keep measuring as we move along. And then verify our assessment results, right? Now, how we approach the whole pilot in more detail, right? So the team, if you look at, this was purely focused on the code and unit test phase of the whole SDLC process. So we focused on coding and unit testing and code optimization. That was the biggest focus area what we were trying to measure. We wanted to ensure that the whole development, coding velocity improvements, maintaining code quality as per industry standards, whatever we are seeing across industry. The other aspects, the technology areas where we were focused, it was primarily around React.js, React Native, and Node.js. So basically focusing on web development, mobile development, and the backend development of it. So all 3 areas of focus were there, which we wanted to do. And then the use cases. We wanted to ensure we cut across all different type of use cases. So from very simple to complex and very complex use cases. So it was a challenge which we want to take, and that's why this duration. So we started this exercise in October of 2023 and went on till February of 2024. So what were the areas on which we were doing, the parameters on which we were doing the measurement using Sonar Cube tool? So we were doing code velocity, code reliability, total quality index. Again, that was very, very important, because while we wanted to ensure we are looking at software delivery and software productivity, we wanted to ensure the quality, how the quality is sustained through, into this delivery process. Code maintainability, unit test coverage, code duplication, unit test coverage for web, mobile, and the backend part, code smells, tech debts, and code security. Again, a very important aspect as we measure all of it. Now, finally, the outcomes for using Gemini Code Assist that we saw. If you look at, and this was just in the release 1, there was an improvement in code velocity. The total quality was improved. I mean, it had improved drastically. The unit test coverage percentages, again, you see a remarkable improvement there as well, and code security. So across all the measurements which we were trying to do, we could see the improvement right in release 1 itself. Now, talking about how we saw the improvement or the changes across all the 3 releases. Now, the biggest part is, if you see, there is a consistent increase in coding velocity which you see happening from release 1 to release 3. Same way, quality index was consistent. Like, there was no drop from a quality perspective across all the 3 releases. Important aspect to look at is, when we look at release 1 and release 2, where we had simple to medium complex use cases, we could see those lot of improvements. But when we started looking at results, varied when we looked at very, very complex use cases in release 3. And again, all of this, as we mentioned, was a mixed team approach. That's what we were also able to see, like, a low pyramid, how they are able to translate and show the productivity. Now, beyond pure development or developer productivity aspect, we also looked at how it is changing the experience metrics. And when you look at experience metrics, it's all about not only productivity, it's also about efficiency. It's also about satisfaction and well-being. If you look at a lot of the people who came in, they felt they could learn coding faster. They could use the time to learn newer technologies. They feel more comfortable on GenAI. And the experience of using chatbots to connect and have a conversation, it created a different set of experience for them. So coding velocity improvement, if you look at, was measured for team with AI and without AI as a baseline. And then stable quality, measured and compared across 9 sprints in release 1, 2, and 3. And this is what we see as a developer experience productivity, which we saw. Now, in conclusion, right, we talked about productivity improvements, code velocity improvements, security-related code standards, which also improved, resolving code quality issues, because that was another big factor which we saw improving. But the other aspects which we look at is efficiency, satisfaction, and well-being. We saw a remarkable improvement in this space. Finally, as I conclude, we believe the decision to embrace GenAI is not merely a choice, but a strategic imperative. It is predicted that 70% of professional developers will be using GenAI technology by 2027. So the question is, if we want to be an early adopter or a late boomer. With GenAI serving as a valuable assistant, organizations will be convinced that the effects were well worth the effort.